welcome to my new video. Our today's question is avoid flood in the city. So you are going to, this question is very interesting and you are going to learn a lot from this question, and I am going to explain this question with using two concept like hash with using HashMap and tree set in the Java, or you can say you can also use either binary search. Okay, and why to use map instead of set, it is also very good question, so you can think like that. Okay, so let's start the question. So you can read all of this stuff, I can directly explain you. So there are lakes in your country, and the all the lakes are initially empty. Okay, and this is the array that they are given, and that is nothing but on day 1 there is a rain on lake 1. Okay, and on day 2 there is a rain on lake 2. On day 5 there is rain on day lake 2. And if on, let's see, on day 2, okay, the rain is on lake 2, so it is filled with the water. Okay, it's full of water. If it rains over a lake that is full of water again, means on day 5 there is a again rain on lake 2, so it is flooded. So our goal is to avoid flood. Okay, so let's understand the question first. Okay, I am going to take another example, not from examples, this is like test cases. I solved this question and I got errors, lot of errors. So after that I got this test case. This test case like covers all the edge cases. So let's take this edge case 10230. Okay, 10230 1 and 2. Okay, this test case cover all the edge cases. Okay, let me explain you. Okay, so for that, let's consider this is 1, that means there is a lake 1. Okay, so let's take lake 1. Okay, and there is a lake 2, lake 3. Okay, so just take lake, first draw the lakes. Okay, this is lake 2, lake 3. Okay, we have 3 lakes. Okay, on day 1 there is a rain on lake 1. Okay, so we can simply fill it. Okay, and we can store the lake in the set. Okay, at the end we are going to use hash map, not set, but for now we don't need hash map. Okay, once we encountered this day, we are going to understand why we need hash map instead of set. Okay, so this hash set denotes there is a rain on lake 1, means after we encountered lake 1 we know that okay there is a rain. So if we again fill this, so there is a flood, so we have to avoid it. Okay, so now on day 1 there is 0, that means we can empty any lake before that. Okay, let's see, on day 0 we can empty 1. Okay, this lake. Okay, but we can't empty these lakes. Okay, because this is in the future. Okay, on day 1 lake 2 and lake 3 are already empty. Okay, this is in the future, so if there is a 0 we can empty lake before that. Okay, this is very silly, but this is important observation. Okay, if there is a 0, so we can empty lake 1 only. Okay, and again this 0, it can empty 3 lakes, it can be empty this 3 lake or lake 2 or lake 1. Okay, this is the key important observation. Okay, now, so for now I am not going to empty lake 1. Why? Because we don't need. Okay, when there is a 1, so at that time we got to know that okay 1 is already filled. Okay, let's see, the array is only this. Okay, so 1 filled, within 0 we are not going to compute. Why? I am going to tell you. Then 2, then I filled lake 2, then 3 I filled lake 3. Okay, and 0 I am just going to store their indexes, means 1 and 4 are the indexes. Okay, this is like store in array list. Okay, if there this is the array, so we don't even need to compute this. Okay, so that's why whenever we encountered 1, at that time we are going to compute and choose which 0 to empty to the lake. Okay, okay, so I am just going to store their index. Okay, for now. Okay, I am going to explain you why, but just stay with me. So 1. Okay, now we are on day 3. So on day 3 there is a rain on lake 2. Okay, so fill this and add it into the our set, that means it denotes there is a already water in that lake. Okay, so now 3, so fill lake 3 and add it into our set, that means there is water on lake 3. Okay, now again 0, we are not doing anything. Okay, this 0 can empty lake 2, lake 3 or lake 1, so we are not choosing now. Okay, just add this index. Okay, after that, 1. Now you can see this is in the set, that means it is already filled, so we have to empty it first if we can. Okay, this is our array list. Yes, there are 0, that means we can empty, but which 0 to choose? Like this 0 can empty uh, lake 1, or and this 0 can also empty lake 1, but which 0 to choose? Okay, this is very key observation, and this is the solution of this question also. Okay, we have to choose this 0. Why? Greedily, we have to think greedily. This 0 can empty this. Okay, but if we choose this 0, okay, like fourth index, the 0 present on the fourth index, if we choose this 0 and we emptied lake 1, okay, if we emptied lake 1, that means this 0 now got like corrupted. Okay, now this 0 is emptied, and now this 0 can't be used to empty this 2. Okay, so this 0 have so much options, guys, like 3 options. Okay, let's, so that's why we are choosing this, because we have to choose the 0 which is just after our leg. Okay, just after our leg. Why? Just let me explain you again. Okay, so let's consider we choose this 0, okay, and we emptied it. Okay, and then this 0 get corrupted. Okay, now we are on 2, there is no flood. Okay, because we emptied it. Okay, now on, when we are on 2, so there is the lake 2 is already filled, so we have to choose. Okay, like this is we use it. Okay, so we can't use now this 0. Okay, now there is only one 0, and this 0 can't empty lake 2. That's why, guys, okay, we have to choose greedily. We have to choose the 0 which is just nearest to the our lake. Okay, that's why. Okay, let me erase it. Okay, so we are going to check in our this list, and I'm going to check if this one can 0 our lake 1. Yes, this is going to do. So we can simply use this okay, this 0 to empty lake 1. So we empty lake 1. After that we are going to fill it again, because on day 5 there is a water. Okay, so we filled it. Okay, and that's why we need hash map. How we are got to know that this one is on index 0? Okay, this 0 is valid just because its index is greater than one index, so that's why we are going to store their indexes. 2 means 2 and 3 means 3. Okay, if this 0 means index 1 is valid only if its index is greater than our lake 1 index. Okay, that's why we need hash map instead of head set. Okay, now for 2, okay, and now this 0 get corrupted. Okay, now we use this 0. Okay, now and in our answer we have to write, like, if they rain, that means we have to write -1. So for everyone we have to write -1. Okay, and if we use this 0 to empty lake 1, so we have to write the lake number, and that is nothing but 1. Okay, now we are on 2, and 2 is already filled. Can we empty it? Okay, can we empty it? Yes, we can empty it. There is a, and after we use, we can simply remove it. Okay, from our list. Okay, now there is a 4. Can we can this 4 emptied this lake 2? Yes, because this index 4 is greater than, like, 4 is greater than 2. Okay, because this is after the lake 2. Okay, that means we can empty it, so we can simply emptied it, and like empty it. After that we have to, if we empty it, so we can simply remove it, and at that time we have to write the like lake number. Okay, and lake number is 2. For this 0 we emptied lake 2, that is the meaning of that. Okay, and after that we have to simply fill it. Okay, and we are using what? We are using array list, but we have to use tree map. Why? Let me explain you. 1 and 4. Okay, if 2 is not here, 2 is over first. Okay, 2 is first and 1 is here. Okay, so what we can do? Okay, let me explain you. Okay, so when we encountered the 2, okay, so 2 is already filled, right? 2 is already filled with the water. Okay, so can this 0, okay, can this 0 empty lake 2? Can empty lake 2? No, because its index is 1 and 2 index is 2. Okay, and 1 is not greater than 2, like this 0 only empty lake 1. So we have to check, can this 0? No. Can this 0? Okay, 4 is greater than 2, yes. So we are, what we are doing, we are linearly traversing on this list and checking if this 0 can empty our list, like if this 4 like index 4 can empty our list. So instead of that, we can do two things. We can use binary search, or we can use TreeMap. TreeMap gives us, like if you use ceiling value, okay, if we use function ceiling, like ceiling, and we pass the index, and index is 2, so it will return us the value which is just greater than 2, so that is 4, and we exactly want that. Okay, so after 2 we want the 0 which is just next to the our lake. Okay, so we can use TreeMap, right? So let me show now, let's start the code. Okay, so firstly we have to initialize our n. Okay, n is equal to range dot length. So what we are doing, we want hash map. Okay, hash map of integer comma integer. Okay, integer map is equal to new hash map, and also we want one map. Okay, tree map of integer. Okay, this is the tree map. Okay, est new tree map of. Okay, now we are simply traversing on our range array. Okay, also we have to create our answer variable. Okay, answer is equal to new int of n. Okay, and when our 0 is not used, okay, so we have to write there 1. Okay, so this is not given in, okay, this is not given in description, but we have to write. So first we can simply fill this with 1. Okay, this answer with 1. Okay, if we are not able to compute, the answer is 1. Okay, now we are simply traversing on our array equal to 0, I less than n, I plus plus. Okay, now we have to check if our range of I, which is lake, if is equal to 0, then we are simply add it into our st. Okay, this is the our tree map. Okay, we are simply adding in our st dot add, or okay, let's I just wrote the whole code because video is getting lengthy. Okay, if rain is 0, that means we are simply storing it in our tree map. Okay, after that, if rain is not 0, that means our answer of I is equal to -1. Okay, if, and this is given in example, range of I is greater than 0, that means we have to write -1. Okay, and if this is present in our map, that means on 2, let's say 2, this is present in our map, that means this is already filled with water, so we have to empty it first. Okay, and we have to check if we can empty it. Okay, so we have to take from our tree map index. Okay, so this is ceiling value, so we can simply pass the index and it will return us the next big integer. Okay, let me explain you. I already explained you, for 1 and 4, this is our tree map. If we pass 2, so it will return us just greater than 2. Okay, and that is 4, and it is our value. This is what we are greedily thinking, so this will return us 4. Okay, and if it is null, that means we can't able to empty this lake, that means we have to return empty array, and it is given in example. Okay, and after that, answer of it is range of I, that means, okay, if this is 2 and we are choosing this 0 to empty lake 2, so we have to write for this answer of, okay, for this index we have to write 2. Okay, so that's we are writing here. Okay, so answer of it, this is index, it's range of I, so we are choosing this lake to empty with 0. Okay, and after that we have to remove this from our tree map. Okay, because we are using this 0, after that we have to put the new index of. Okay, and if, like, let's say if this is not present in our map, so we can simply store the index. Okay, like put the lake and with its index, and after that we can simply return our answer. Okay, Let's try to run it. Yeah, it is running. And let me show you another variation. Okay, I solved this question. There is another variation I solved by using binary search also. Okay, so you can use binary search instead of what instead of tree map you can use binary search. So this is array list. Okay, so we are passing our index and st is our list. Okay, so we are just doing binary search. Okay, if we are finding mid, that this can be potential answer. If this is a valid, that means its index has to be greater than our current index. Okay, if this is valid, so answer, we are simply storing answer. And if this mid is valid, that means mid plus 1 till high is everything is valid. Okay, so we are simply reducing high to my mid minus 1. If this mid is not valid, that means from 0 to mid everything is invalid. So we are just writing our loop is equal to mid plus 1. Okay, and this solution was not fast enough than this, just because tree set is internally very fast in Java and binary search is not fast. So let's try to submit it. Okay, yeah, it is get accepted. Thank you so much for watching. If you like the video, make sure to like, share, subscribe, and if you have any doubt, make sure to comment.